Hello guys, in this video we will discuss the merge sort. We have already discussed the three sorting algorithm, that is bubble sort, selection sort and insertion sort. So this sorting algorithm is different from other three. So it is a divide and conquer algorithm. So let's see what is divide and conquer algorithm. So in divide and conquer algorithm, we are having the two step divide and conquer. So in dividing step, what we do is we divide our problem into the smaller problem. For example, if I am having this vector of size 9 element, so we'll divide this array into the smaller array, and if we will keep on dividing until we do not reach to the smallest problem, and then we will reach to the smallest problem, then we will start to merge. Then we will merge the solution of the smallest problem to build the original solution of our original problem. So what I want to tell you, it will make more sense when uh, I will discuss the example here. So let's talk about this example that I have written down here. So, okay, so I have the element, I have the 9 element here. So, what we will do, we will take the two index. One is L, one is R. Uh, one is at the beginning of the array, and one is at the end of the array. So, what we will do, we will divide this array into the two equal part. So, how we will divide into two equal part? We have to find out the mid index of this vector. So we know that how we find the mid index of array. So we have the formula L plus R by 2. It is mid, but what is the problem with this formula? If L and R is very large, so N plus R can lead to the overflow condition. So to avoid the overflow, same thing we can write same as L plus R minus L upon 2. Okay, so we will find the M. So in this case, M will be 4. Okay, and we will divide the array from L to M, and M1 is M plus 1 to R. So we will having the two array. One will be 23, 12, 10, 43, and 54, and other will be 32, 66, 44, and 58. Then we will divide our array further, and this will be 23, 12, 10, and this will be 43, 54. And then they will divide this also. Then we keep on dividing until we do not reach to the smallest problem. And what will be the smallest problem in this case? When we left with the single element, because single element will is sorted in its own way. Okay, uh, so it will be 43, 54, it will be 10, it is 32, 66, 44, 58. It will again divide into 23 and 12. Okay, now we will start to merge. So 23 and 12 will be merged. Okay, so 23 and 12 will be merged to make the sorted array. So when 23 and 12 will be merged, so 12 will be appear first, then 23 will be appear first. And how this merging take place, we will discuss it later. So let's assume that we have the two array, and when we will merge these two array, then it will become a single sorted array. So 10 and 12 and 23 will be merged, then it will be 12 or 10, 12. 23. 43 and 54 will also be merged. So it will become 43 and 54. It will become 32 66. And this will become 44 58. Okay. And one thing is also that in order the order in which we have divided the array in same order we will merge them. So now this array will be merged. So this will become 10, 12, 23, 43, 54, and then when this will be merged then it will become 32, 44, 58, and then 66, and then these two will be merged to form a sorted array. This will be our last operation, last merge operation, and we will get our final sorted array. So it will be 12, 12, 23, 32, 43, 44, 54, 58, and 66. Now this array is sorted. This is sorted array. So how this algorithm is working? First of all, we are finding the mid index, then we are dividing the array into the two equal parts, and we keep on dividing until we reach to the single element, until we reach to single element. And after dividing, we are merging the solution. So how are these things going on? So algorithm will be work like this. We will have merge sort function. Okay, so we have an array and index L and R as we discussed initially. We have L and R and an array. This is an array. Okay, array or vector. Okay, so we have these three things. So it is for sure that L should be smaller than R because left index should should always be smaller than R. Then only we can move further. So when L is smaller than R, then we will what we will do? We will call the merge sort recursively. We will first of all we will find out the mid index. Okay, so we will find out the mid index. The M will be L plus R minus L by 2. So we have found out the mid index. Then we will call the merge sort function recursively on the array L mid and array M plus 1 R. So this merge function now is calling on the array from L to mid, and this from M plus 1 to R, like in this case, like we have discussed. uh, this array is from L to M, this from M plus 1 to R. Okay, so we will call recursively, and after when recursive call of this function will be end, then we will merge the solution. We have to write the merge function which will merge these two solutions. So we will pass L, M, and R to this function. And how this merge function work? So let's discuss the merge function. So okay, let's first learn the intuitive idea of merging. So I am taking the last merging operation. You can do any. You can take any merging operation. I am taking last merging operation. All the merging operation perform in the same way. So we have the two array. We have two array. One array contain the 5 element which is sorted and one element is contain 4 elements which is also sorted. One array contains 10, 12, 23, 10, 12, 23, 43 and 54, 43 and 54, and here 32, 44, 32, 44, and then 58, 66, 58, 66, 58, and then 66. Okay, now we have the two element here. Okay, so what we will do here, we will have, and we also having our original array, which consists of, in this case, when these two array will be merged, then this contain 5 element, this contain the 4 element. So it will be placed into the original array, which having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 index. Okay, now and these are 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. These are the individual array. So indexing of both the array will be from the 0 to length of the array. Okay, so this is our original array. So make a we will put a pointer I here at the beginning of the first array, and the uh, pointer j here at beginning of the second array, and one pointer will be to the original array where we want to copy. We know that if we combine this array, then what will be happen? This will be start from L. This will be start from end with R in the original array. Okay, this is not this is not necessary that it is this zero index pointing to this zero index, because if we will see this diagram, if we merge 43 and 54, then 43 is at 3 location, 54 is at the 4th location. So it is not necessary, but it is individual array which is of length 1, and index of this is 0 and 0. But in the original array, 43 is at the 3 and 54 is at the 4. So it is not necessary that index of this and this is remain same. Okay, so I hope you understood. So what we will do now, we will put, for in this case, L and this I is same. Okay, so this is also the L, this is R. So we will make the pointer K to L. Okay, now we will compare. Now we will compare if, let's say this is left array and this is right array. So we will compare whether left of I is smaller than or equals to right of j. If it is, then what we will do? We will copy the left of I to array of k. Okay, and we will increment k pointer and as well as I pointer. Okay, so in this case, if we will compare the 10 and 32, so 10 is smaller, so 10 will be copied to the location pointed by the k. So pointing k is pointing this location, so 10 will be copy here, 10 will be copy here. Okay, and also I will be incremented to one pointer and k will also be incremented to one pointer ahead. Now again 12 and 32 will be compared. So we will see 12 is smaller, so 12 will be copy here. So 12 will be copy here and k will be incremented to again, and I also will incremented to here. Okay, now 23 and 32 will be compared, then 23 will be copy here, k will be incremented to here, and I is incremented to here. Now 43 and 32 will be compared, then 32 will be copy, and j will be increment, and also k will be increment. Now 44 and 43 will be compared, then 43 will be come here, and then j will be k will be incremented here, and I will be incremented here. Then 54 and 44 will be compared, then 44 will be come here, and k will be point be moved further, and now j, okay, we copy from this array, so now j will be moved ahead, and then 58 and 54 will be compared, then 54 will be come here, and then k will move ahead, and I will move ahead. Now I has reached to the end of the array, now it has crossed the boundary. So now if we will access the array of I or left of I, then it will generate the exception. So that is why what we will do, we have to compare till I is smaller than n1 and j is smaller than n2. Okay, so this thing will be happen. If left of I is smaller than right of j, then left of I will be copy, else right of j will be copy. Okay, right of j will be copy, will increment k and j, and this will keeps on going. And when when one condition is any one condition is not satisfied, whenever I is become equal to n1 or j becomes n2, then this while condition will be terminated. Now after this condition will be terminated, we have copy all the elements from the left array, but we are left with the right element of the right array. So what we will do, we have to check whether any index is reached to the end of the array or not. We will check if while we will check while I is smaller than n1. In this case, I is reached to the end, but there can be the condition when I do not reach to the end, but j reach to the end. So we will check. We will copy left of I and will increment I and k. And similarly, we will check for j while j is smaller than n2. Then what we will do? We will do array of k is equals to right of j, and will increment k and j. And this is the only operation of the merge. This is the merge. This is a merge function. Okay. This is the merge function. Now, okay. So I when this while loop is terminated, then it comes out of the loop, then it will check I is smaller than n1. No, this condition will be false. This condition will be false. Now it will check whether j is smaller than n2. Yes, j is smaller than n2. So it will copy the all the element from right array to here. So 58 and 66 will be copy, and j will also be reached to the end. Okay, and the whole array has been copied, and we got now this array, and now this array is sorted. Array is sorted now in this case. Okay, Now we have merged these two array and we got the sorted array from these two array. Okay, now let's discuss the time complexity of the merge sort. So what would be the time complexity of the merge sort? So let's discuss the time complexity. So here what we are doing, there are only the two operation, dividing and merging. So how many times we are dividing? I- Initially it was having n size, then the array become n minus 2 size, then n minus 4, then n minus 8, and so on. Okay, so it will keep on decreasing by half, n minus 8, and so on. So it total number of times will be log n. This will be log n, and we know, and this will be log n times. Okay, and what will be the time complexity of the merge operation? Merge operation we have the condition on n1 and n2, and in the worst case n1 plus n2 can be n when l is 0 and r is array dot size dot minus 1. So it will be n, I will be incremented till 0 to n plus 1, and j will be incremented from 0 to n2. So we have total iteration is n plus n2 only. So it can be in worst case order of n. So total iteration will be n times. So when we discuss the time complexity of the merge sort, then we know that we are uh, dividing the array. We are finding the mid index and we are dividing the array log n times. And in log n times, merge sort is calling each time. So and merge operation take order of n times. It will be order of n log n times. The time complexity of the merge sort will be n log n. Okay, yeah, that is the simple algorithm. I have discussed the general idea of this algorithm work. You can write the code by your own. If you get any difficulty in writing the code, then you can watch the next video where I have discussed the code of the merge sort. Okay.